A very good morning, students. Today, I would like to teach you the quadratic equations. In fact, this particular topic already you have learned from class 10. That's why I have chosen this topic to reconnect and also to recapitalize your concept. Now, what do you know about the quadratic equations? Maybe you know, maybe you also do not know. Number one. Number two also, that another questions naturally arises that why we also learn quadratic equations. Why you can apply this. Whenever you are learning any topic, children, you must be knowing that why I am learning this. Now, you know that a quadratic equations basically has come a quadratic polynomial. Now, what is the quadratic polynomial? The quadratic polynomial basically written in this way: f of x is equal to ax square plus bx plus c. From here, whatever the equations are generated, that is called the quadratic equations. Now, what is this x? This x is known as the variable part, single variable definitely, and this a, b, c, these are actually the constant real numbers. So a, b, c actually constant real number. That means this c also can be 0, this b also can be 0, and this a is also can be 0. I will come one by one that whenever this polynomial it will come in this shape, that is ax square plus bx plus c is equal to 0, then this is formed as quadratic equations. Quadratic equations. Now, this quadratic equation is also known as the standard form or the general form of quadratic equations. If this b part is 0, if this b is equal to 0, then also it will have a quadratic form. Then it is called the pure quadratic equations. That is ax square plus c is equal to 0. This form is known as pure form, and this form is known as standard form. So this is the first fifth query what I have defined you, that what is a quadratic equation. Next is that the next question is very simple. That is why we learn these equations, why we learn this topic, why you can apply it. See, people who are mathematics is very much related to physics, chemistry, even in commerce, economics, where they can apply this particular concept. Now, as far as your if you are a commerce student, you can apply this equation particularly in so many writing the diagram. For example, if I draw this diagram like this, this is actually a parabolic form. This parabolic form actually represents our quadratic equations or quadratic polynomial, quadratic functions that you'll be knowing over the time as the class progresses. Even kinetic energy, or in physics, or in other cases also, say gravitational force, the way if we throw a ball, the way it falls on the ground, that is in physics. But over there also we know that it also follows. It also grounded in parabolic form. So everywhere you can apply, and we know if we know the particular equations of that particular trace or part of that body, we will be exactly knowing what is the equation and how it goes or how it moves along the path. So because of the reasons, with the objective of that, we generally learn the quadratic equations. Now, once we learn that why you are learning it and what is the form, our next thing is that in these quadratic equations, that is if I write ax square plus bx plus c is equal to 0, in this particular form, a quadratic equation, it has how many roots? Children, you just see that here in this particular part, this x variable has high and it's a polynomial, so its degree is 2 because its highest power is 2. This power 2 is actually telling you what? This highest power 2 is actually telling you it has two roots. Two roots. Now, how surely we can prove that it has two roots? Suppose one student can tell me, no sir, it has three roots. So let me prove that these particular equations have only two roots. It cannot have a three roots. Let us try to prove it. Suppose, as per as your logic, if you can know sir, it has a three roots. Okay, fine. I assume that okay, it has three roots: alpha, beta, gamma. Okay. Now over the here I will prove you. No, it cannot have a the three roots. It must have a two roots. Just see how am I proving it, and that will give an interesting interest. Yes, that why you are learning also that why it has two roots. Suppose if alpha is the root of this equation, definitely this alpha will satisfy this equation. So we can write this as a alpha square plus b alpha plus c is equal to 0. Similarly, if beta is the root of this equation, I can write this as a beta square plus b beta plus c is equal to 0. Similarly, if gamma is the root of this equation, I can write this as a gamma square plus b gamma plus c is equal to 0. So, it has three equations: equation number 1, equation number 2, and equation number 3. Now, from 1 to 2, if I subtract, I can get subtract 1 minus 2. So what you can get? If I subtract it, I will get a into alpha square minus beta square plus b into alpha minus beta. C is cancelled. This should be equal to 0. And if I take alpha minus beta common, I can get a into alpha plus beta plus b is equal to 0. Similarly, if I subtract from say 2 to 3, from 2 to 3, 2 minus 3, I will get a into beta square minus gamma square plus b into beta minus gamma. CC again will be cancelled. I will get these equations, and hence I can get beta minus gamma into a into beta plus gamma plus b is equal to 0. Just the factorization, nothing complex over here I am doing. Next is if you subtract from 1 to 3, I will get a into alpha square minus gamma square plus b into alpha minus gamma. Again it will be 0, and therefore if I take common alpha minus gamma, I will get a into alpha plus gamma plus b is equal to 0. So equation number the equation number from this subtraction I have got these equations. From here I will get these equations. This is equation number 4, this is 5, and this is 6. So if I see alpha minus beta is not equal to 0. It's a factorized form in class 10 you have learned. Beta minus gamma is not equal to 0. Therefore this cannot be 0. Similarly, alpha minus gamma is not equal to 0. Therefore I can write over here that a into alpha plus beta plus b is equal to 0. This one, this I can write. Similarly, from 5 I can write a into beta plus gamma plus b is equal to 0. Similarly, from 6 I also can write that a into alpha plus gamma plus b is equal to 0. This is equation number 7, this is 8, and this is 9. So once we understand this, from now concentrate children on these three equations. In these three equations, a into alpha plus beta is equal to plus b is equal to 0. Similarly, a into beta plus gamma plus b is equal to 0. Similarly, a into alpha plus gamma plus b is equal to 0. So once you understand this, now from 7, and if I solve these two equations, if I subtract 7 minus 8, if I subtract 7 minus 8, from 7 minus 8, I will get what, children? You see, a into alpha plus beta minus gamma, this is equal to 0, and this beta cancel. Therefore, we have proved that alpha minus gamma is equal to 0, and therefore alpha is equal to gamma. Okay, this actually proves you that alpha and gamma is same, and therefore the three, it cannot have three roots, it must have a two roots, that is alpha and beta. Thank you very much. Today I have proved this. In our next class, I will try to reconnect again with you or your known part, that is whatever you have done in class 10, that is factorization. In the meantime, you please revise that, particularly Siddhartharia's formula, application by factorizing method, how can you solve the quadratic equation. So all these things you will learn, and over there we will also do some difficult sum what you may not have done in class 10. Thank you very much.